but I am here to talk about Masher. So Masher is an open source project that I recently came off of, joined together with 2 other friends, and had the rare opportunity to just build an open source project that you were excited about building. So I'm really excited to share with you today some of my experiences from doing that. So to do that, I'm going to talk about what Masher is, what data pipelines are. We have to talk about that to know what Masher is and what kind of problem it solves. And then we're going to talk about some of the challenges of creating your own data pipelines. There is just an immense amount of tools and frameworks and platforms out there that you can create a data pipeline from. So I'm going to try and narrow that down to a particular use case and talk about ways that other proprietary and open source solutions solve the problem that data pipelines seek to address. And then we'll talk about how Masher solves the problem and some of the design choices and challenges that came up along the way. So first thing, broad overview, what is Masher? Masher is an easy to use open source data pipeline orchestration and monitoring framework for small applications, which allows you to take data from multiple sources and combine it so that you can use it. So it's okay if that's not all clear. We're going to get into more detail. Specifically, it's a CLI that's built in Node.js, published as an NPM package, so you can go on GitHub and download it now. Uses GCP services, and it uses a tool called Imbolc. Anybody heard of Imbolc? It's kind of like low-key right now. Imbolc, that's hosted on Docker containers on Google Compute Engine instances. So we're going to get into more detail about what that stuff means. So we chose Google Cloud Platform. There's a lot of cloud platforms out there. We went with GCP just because we felt like there was a number of robust machine learning and analytics tools available to GCP. There were some other reasons as well. BigQuery tends to be a little bit more abstracted than some of the other solutions, which fits our use case, but I can get into that more. So first thing, what's a data pipeline? Data pipeline, real simply, is just about getting data from point A to point B, from source to destination. But the reality is there's actually a lot more decision points and design questions under the hood about forming a good data pipeline. So imagine this, you're a developer at a small application, and you've got data sitting around in a bunch of different sources. You want to combine that data and use it. This is a pretty common scenario for small companies. We're really thinking about developers who work for small applications. So specifically, let's think about a company called Bookin, and they sell niche books, and they have MailChimp for email marketing. They do sales on Amazon, and they have another e-commerce platform, right? So they just want to get data into a single database so that they can say, well, how many emails resulted in sales or in our 2 different sales platforms? It's a pretty straightforward thing, right? So first thought, developer says, oh, I can probably just have a simple application hosted on a virtual machine or wherever, or even a Lambda or Cloud Function, and that's just going to make some API calls, send it to the database. But there's usually a little bit more if you're a production-ready application, right? The first thing is, well, a lot of those databases, if you try and send the wrong format, LoadJob's going to fail. It's just going to stop working, right? And then it's going to try for the next one, and the next one, if they're all in the wrong format, it's just going to stop working. None of that data gets loaded, and you lost all that data. Now, as a developer, you got to go back and look again and figure out where to pull, where it messed up, why it messed up, all those things. So you want some kind of staging location. Data goes there, tries to load it to the database, and that way, if it fails, you can go back and debug. Now you have a place to go look. Oh, something went wrong. Maybe I can figure out what went wrong. Or if something, right, it does load to the database, but the data's corrupted. Well, was it corrupted because of your data pipeline, or was it corrupted before then? What happened to get it corrupted at that point? Having an archive of successful jobs as well is also useful for that scenario, and because you might want to do audits or compliance reports. So generally, we're going to have some place that the data sits before the database. And most often, we're going to want to do some kind of validation or transformation, right? Is the data that I think is there, is it actually there? Or transformation, like, or like they all have a date field. I want to make sure that it's in the same format or something like that. And then lastly, you know that as a small but growing application, you're probably going to add more data sources. right? This is not it. Maybe you have a MongoDB database from another application, or you've got a PSQL database or something else, and that isn't a REST API. And you want to, in an easy way, without a lot of overhead, to just have a new source of data that connects to your existing data pipeline. So this is the problem that a good data pipeline seeks to solve. Complicated data pipelines can look have a lot more going on than this. But for them, this is pretty much the setup. They want modular plugin-based loading, staging, archiving, and validation, transformation. And they probably want to have monitoring in each step of the way. So let's talk about what some of the principles or components are of a good data pipeline for our use case. So first is that you'd want to have something that extracts from the source. Seems self-evident, but there's actually hidden complexity there. The data could come to you from in XML or CSV or JSON. You get to format that data before sending it into a format that the destination database can read before sending it over. You also have to worry about scheduling. Could be a cron job or some other scheduling service. You usually want to perform validations like I was talking about. And that could look like, all those same date formats. Is it the right format? If you're in a financial database that has financial data for the last year, is the date field only contain dates from the last year? Transform, so transformations are just doing, it could be where you're doing some aggregation, you're actually reducing the amount of data, or it could be things like encoding freeform values. That would just be like, source data has male, you want to translate that to M. Or translating coded values, that could be source data says 1 is male and 2 is female, you need to translate that to M and F. So usually, as I was talking about before, you're going to want to not send the data directly to the destination database. There'll be some sort of staging and archiving area for audit reports and compliance, but mostly for diagnosing and debugging, and so that you can roll back easily if there's corrupted data or if for any reason data fails to load. Another area that's a little bit, that has hidden complexity, seems simple, is actually loading data. For a lot of services, you may need data in real time, so a lot of cloud platforms offer some sort of streaming service to load data. Ours uses a batch loading, which is just like, I'm going to take this chunk that I need and this chunk one at a time. Monitoring is super important. So in monitoring, you're going to want to monitor every step of that way. There should be a log kept. What data was loaded, what errors occurred, if any, and what action was taken. And that way you can actually go back at any point in time and figure out what went wrong where. And then in larger systems, you have to worry about orchestration and ordering of tasks, right? Like C and D depends on a condition in B, B depends on A happening. And this can be something that you have a concern about for larger systems. Also, for any systems, you want to think about performance. What optimizations can you make, and where are bottlenecks? Most bottlenecks are going to occur from loading or extraction. And so as an example, like extraction, lots of APIs have throttling, or maybe there's read limits. Loading, there's going to be write limits to a destination database. So your system has to think about how it's going to handle those bottlenecks. Optimizations, lots of systems might use some kind of parallel processing. Maybe it splits a file up into a bunch of smaller files and processes them concurrently. And so once you've figured all that stuff out for your data pipeline, which pieces you need, which you don't, you got to think about the order. So normally, I think everybody hear of ETL, right? ETL, extract, transform, load, is something that we talk about for data pipelines commonly. This is the traditional process, actually. So we want to transform before we load because the cost of storing data used to be more prohibitively expensive. And so transformations might be aggregating, like you're going to aggregate data, you're going to make it smaller, right? Before you load, so you could save on cost. But nowadays, with cloud platforms, it allows us to actually load the data first, and you can do whatever transformations you need afterwards, and that's because the cost of storing data is cheaper now. So overall, like broad summary, right, we have data extraction component, staging and archiving, transformation and validation, and data loading components. And the order that happens in is different depending on your needs. So right? So these are all the things that you got to think through when you're going to build a data pipeline. It's no longer that simple API call, right? You got to now think about what are all the different edge cases and scenarios that I want to consider for failover or monitoring or archiving. And not only that, but usually you're not going to build your data pipeline in a vacuum. You're using other tools to do it. So we use Google Cloud Platform, as I was talking about. So I want to talk about what it might look like, some of the challenges you might face if you went about building this data pipeline on Google Cloud Platform. Right, cloud platforms like GCP or AWS are supposed to abstract away a lot of things and make it easier, but the truth is, actually, they also come with their own technical difficulties. And one of the biggest ones for anyone who's ever touched these is that there's an overwhelming number of configuration options. And to make a sound choice, you have to know enough about each option. So you're first looking at GCP, you could look at their data transfer service, data flow, cloud functions. Do you want to host an application on a Google Compute Engine instance? All of these different things, and you're going to have to research and know each one enough to be like, yeah, that fits my use case. And not only that, but they're coming out with stuff every day in these areas. So they just put out Cloud Run, super cool. Actually, maybe it's like a month old now. Wish they had it out when I was building this. Cloud Run is like Lambda function, but with containers. So you can run any other OS on it. Client libraries may not be complete. So we discovered that there's no Cloud Function client library in Node. Many tasks are actually comprised of a series of smaller tasks. So you want to choose a Google Compute Engine instance. Okay, great. What OS, what memory, what disk, everything else that you need. You want to choose Google Cloud Storage. You want cold line storage. What's the other one? Nearline storage, something else. So there's a bunch of other decision points you have to make. It ends up being a lot of decisions and a lot of thought that you have to do. And so we wanted to make that a little bit easier. Just to give an idea, in ours, we make 23 API calls to GCP, and we use 7 different services to set this up. So all of that is why there's a lot of solutions out there. So we break these solution groups into 2 big things. We call it hosted and self-hosted, which is another way of saying proprietary, mostly, and open source, mostly. So hosted solutions, there's a bunch. There's a huge amount of them because problems just like this are real problems that developers face every day, from big to small applications. And you get everything from Informatica Power Center, which could be like 6 figures and is huge, to Stitch and Fivetran, which are really for smaller or medium-sized applications and are like a drag and drop UI. I say medium-sized, but I think Foursquare actually uses Fivetran. So as an example, this is Stitch. I don't know if you can see it, but basically if I was the user, I would click, yes, I want my data to come from AdWords. And then I'd put in my credentials, and then I'd say, yes, I want my data to go to BigQuery, right? And then you'd set up a data pipeline just from doing that. So pros, right, is that everything's abstracted. You don't have to worry about stuff if you're going to use a hosted solution. There's a UI like Stitch that I just showed you. It's very easy to use, just some clicks. And so you can save on time. It probably manages failover in some way. What happens when something fails to load? Probably thinks about a lot of things for you. Cons are, does cost money. Privacy, and by that I mean that data now lives on someone else's servers, right? At some point it has to go live on their servers. And then control and customizations. What if you wanted to do something a little bit different than what they do? Or you wanted to provide some kind of transformation of that data before it reached BigQuery that they don't have? Well, you're out of luck. You have to do it somewhere else. So self-hosted solutions. There is a bunch of self-hosted solutions or open source solutions out there. One of the surviving or biggest ones is this thing called Pentaho Data Integration. There's a bunch of other ones, Talend and some others. And so you can see here, there's like an extraction component, transformation component, loading. It's got a drag and drop UI, but it's also very complicated. It has a bunch of different tools that you can use. The pros of those self-hosted or open source solutions are that it's customizable, right? You can go in, you can edit or extend the code. It's open source. And it's built to be, probably, for most of them, modular or extendable. It's cheap, but not free. The data is yours. The data lives on your servers or wherever you're hosting it. It's not free. You still have to think about hosting. there is a cost in terms of time. You got to learn this new system. If this is not your primary role at Bookend, then there's a decision about how much time do I get to invest to actually do this. And then you probably have to think about scheduling, failover, backup, monitoring, all those things. Not always, but most of the time, you're going to have to think about that yourself still. So I want you to remember our use case, small application. We want to get data from multiple sources, put it into a single destination database so we can use it. And so with that, and as developers, right, we want something that maybe sits in the middle and isn't quite reaching the use case that those proprietary or open source solutions do. So we want something that's somewhat customizable, but also somewhat abstracted, right? So in those self-hosted solutions, those are more customizable, but less abstracted. By abstracted, it's how much of the hosting, management, and everything else do you have to think about? By customizable, I mean how much can you edit or extend the code? So Masher allows you to set up all the resources. It's opinionated about what should happen on Google Cloud Platform. So in that way, it is less customizable than an open source solution. But it's also a little bit more abstracted than an open source solution because it's opinionated and it's going to make those design choices for you. Right, so Masher is an easy-to-use data pipeline framework, orchestrates moving data from external sources, could be a REST API, could be PSQL or MongoDB, into a single destination database where it can be used. This is a convenience framework, we wanted it to be easy. So this is, you do everything with a configuration YAML file, and then Masher deploy, and you can see all the resources on GCP are created for a data pipeline. So the pros, data is yours. It's only going to live on the server that you tell it to live on GCP. It's customizable, it's abstracted, mostly but not all the way. It manages archiving, failover, monitoring for you. The cons are that there's still a server somewhere, and if it breaks, it's up to you to fix it. So it's not completely abstracted from you. We don't use streaming, we use batch loading. So if you need data in real time, it's not it. And it requires a GCP account. So before I get into some of the details about what services it uses and why, I just need to make sure we know what services are on GCP. And so what I'm going to do is just kind of name them briefly and also their AWS equivalent. So a GCE instance is Google Compute Engine Instance. It's a virtual machine like EC2 on AWS. GCS, Google Cloud Storage, it's S3 on AWS. Cloud Functions is a function as a service that is Lambda on AWS. BigQuery is a data warehouse similar to Redshift on AWS. And Stackdriver Logging is monitoring and logging service that you can attach to everything inside of GCP, similar, I think, to CloudTrail and CloudWatch in AWS. So another tool that you need to know is Imbolc. So we chose Imbolc as this data extraction component piece that we were talking about earlier. There were other choices. We liked it because there's a good open source community. It's a well-maintained code base. And so that's what we went with. And basically, we wanted a way that a user would be able to provide input. Like say, I want to pull from PSQL database. And here's the details, my credentials for that, without actually providing a lot of code and overhead for it. So Imbolc allows you to do that. You give it an Imbolc config YAML file. There's an input and an output type. It's built in JRuby and uses gems as plugins. So for instance, maybe there's an HTTP gem for REST API that you're going to pull from. And this one here, HTTP, in, out, GCS, what bucket you're sending it to. And then it just communicates. Imbolc allows those gems to communicate with each other via standard Ruby objects. And then when you want to actually run that job, you do it in the command line, Imbolc run and the name of the YAML file, or Imbolc run name of the YAML file and this -c diff.yaml. That allows you to do incremental loading. So for instance, in a PSQL database, you don't want to load all the records every time. You want to load some of the records each time, only new records. And so with that, you can say incremental true, incremental columns, created at ID, And what this does when you run this is it's going to create a diff.yaml file, and it's going to keep a record of the last created at an ID that it loaded, and it'll use that next time to determine what fields it should be loaded. So I'm going to give a broad overview of those components, how it works. Can we see that? Yeah. So broadly, we got the Docker, we got in bulk hosted on Google Compute Engine, Cloud Storage, Cloud Function, BigQuery, and Stackdriver logging. I'm going to kind of break down the process. You can see, I don't know if you can see it, but this says in tiny letters, Postgres database. That's the source that it's pulling from. So just starting with the in bulk on a Docker container. So originally, I mean, we would have loved to have hosted this on a Cloud Function or something like that. Host in bulk on a Cloud Function or something like that. So that we could reduce costs, but it's written in JRuby, not a runtime supported by Cloud Functions. So we have to host it somewhere, so we host it on a Compute Engine instance. This raises the question, well, what happens if the OS is discontinued? For instance, Debian 8 was discontinued recently on GCP. So we have it on a Docker container, so we make it more portable. It has a cron job running inside the Docker container that pulls data from the source by running that in bulk run every 10 minutes. And in order to do that, we had to have a custom image that's built each time. It's different. We can't just publish and send it to Docker Hub and then pull it each time. It's different because there's different gems, different run commands, so we build it each time in Docker. And it has a couple other features. It stays on permanently by using this tail F command down at the bottom, instead of closing down after a process. So it loads that data into Google Cloud Storage. I'll talk about the archive bucket in a minute. Loads it into staging bucket, which then triggers a Cloud Function to run. Earlier, there was a folder in the user's current working directory that was created that maintains the code for this Cloud Function. So you can add transformation or validation for that data in that code and just re-upload it. So it's going to try and load this data, do whatever transformation or validation that you put in, try and load this data into BigQuery. If it's successful, it will move into the archive bucket. If it's unsuccessful, it will stay in the staging bucket along with a timestamp. You're able to debug errors that occurred. And then everything has Stackdriver logging enabled, including from the Docker container itself. And at the very end, it also searches for a table or data set in BigQuery that you would have provided in a YAML file at the start. And if it doesn't exist, it would create one. So it was meant to be simple, right? So there's just a few commands: init, deploy, destroy, and you got list all the integrations, and help. So init would be the first step that you take if you were using this. Init will create a copy of a template file and set it into your working directory. It says, please fill out the empty fields in the masher config file. You can see, current working directory, you can see this is what it puts in there. There's actually a bunch of comments that I didn't include that also help you to know what each field in the config file you need to fill out. This is it filled out. So you can see it's got a key file for GCP credentials, table and data set ID, integration name. That's going to be what's used to create the Cloud Function, BigQuery, Cloud Function, GCE instance, and Cloud Storage buckets. And then it's also got the run command that you want to use and the gems that you want to use. And then everything below here is for in bulk when we launch it. And that's the input type that it's going to use. So here, the input type is HTTP, has a URL, method get, right, and what the schema is that you're pulling in. So and then deploy, once you have that masher config file filled out, deploy does all the heavy lifting for you, creates that bucket and function, and archive and staging buckets and GCE instance. So I'm not going to get into all the details here for the sake of time, but deploy generally does local validations, has to do a bunch of remote validations, right? Because it has to make sure that the integration name you provided can actually be used for Google Cloud Storage, Cloud Function, and everything else. And Then it launches all of the GCE resources that we talked about in the correct order. And then once the GCE instance, Google Compute Engine instance is up, it's got the Docker container running, it instantiates the container, and starts a cron job. And then destroy would destroy all the integration, destroy the integration that you had. Yeah.
Why cron job?
What's that?
Why do we use cron job?
I'm going to get to that actually at the end, because there was a design question there. Yeah. So as a summary, Masher does data extraction through using in bulk, allows a user to give custom validation and transformation, provides for staging and archiving, loads data to BigQuery, and is monitoring enabled for each part of that. And there are some questions around orchestration and performance that I don't want to get into here. So challenges. So there's three main things to talk about in design choices here. So the first thing is that we're using Docker in a non-standard way. Normally, or ideally, you could just publish Docker to Docker Hub. You could use that as your basic template. For ours, every time that we launch an integration, right, the Docker image that we create is going to be different because it's going to have different gems installed and a different run command that's being used, different files inside of it. So to do that, we have template files, including a Docker file, that are then converted into strings. We take the values from the Masher config and fill in those template files. There's a startup script in GCE instance that is used to then, as strings, import all those files into the GCE instance. And then we run the Docker file. Docker file has copy commands inside of it that then copy those files inside of it. And then we run the container. And Docker cron jobs. So there's a question like, well, where should we put scheduling? Inbulk doesn't schedule itself. And there's some other very promising options that we could have used. So the first one is that you could put the cron job on the GC instance, the virtual machine that the container runs on. So I can cross that one out right away just because we don't want more dependency on the OS. We're already using Docker to do this. The two other ones are similar. We could use Cloud Scheduler, which is GCP's built-in cron service. Or we could use a cron job that runs in a separate Docker container. And those make sense because it's about separation of concerns. It has a particular concern that you want to use it for, and it makes sense to put it in a particular space. However, just because of the time, or just because of our specific use case, we had one Docker container. We didn't feel like it warranted the kind of setup and infrastructure for a separate one. So we made the decision that it was okay to have the cron job running inside the Docker container itself. This did open up the question of, well, most Docker containers, right, they have a process, they start and they stop. But ours needs to be kept open because there's a cron job running on it. So you can keep it open with the last command being tailf, something, and that will watch a file indefinitely. We also have a restart policy of true when we run it, just in case. So lastly, right, we wanted all of that power of Stackdriver monitoring and logging, so that the user would know exactly what happened where. So originally, if there was an error on that Inbulk had, or something went wrong on the GC instance, the user would have had to SSH into the instance, exec into the container, and then go and tailf or print out the logs and try and figure out what went wrong. We didn't feel like that was really a best case scenario. So the way that we were able to get those logs out was there's a GCP logging driver that you can use when you do the run command for the container, or when there's a daemon.json file that's a configuration file for Docker that you can use. So we do it in the run command, we use the GCP logger, but just because we have that doesn't mean that the output of your cron job will actually output to the process that Docker listens to. So this little bit basically puts the 2 and 1, puts the standard error and standard output of the cron job that we're running into a process with an ID of 1. That's where Docker listens for sending logs. It'll forward those logs to Stackdriver. So future work, GCP is not the only cloud provider. It'd be great to do AWS. You could imagine a scenario where a similar setup is used, actually, that's platform agnostic, in that, you know, instead of sending it to BigQuery, you're sending it to Kafka or some other service so that the user could then decide where it goes. We'd love to enable other target destinations. Right now, you have to authenticate with a key file. It'd be a lot easier if it was an OAuth file, or if it was an OAuth. It would be also good if there was some sort of pre-checks on the schema. So if the schema is wrong, it's going to load it to BigQuery. It'll fail. It'd be nice if it just told you ahead of time. The schema is wrong. It's going to fail. We need a redeploy command that allows users to override existing integrations. And then lastly, I would really, this is one that I hope to do soon, the GC instance should be on Kubernetes. And that's just like if we're building it to protect against failover, it makes sense to put it on Kubernetes. And we only didn't at the end because of configuration time for us, because it's an open source project and I wasn't getting paid for it. So, but it's something that I plan to look for in the future. So that's everything. I don't know if I ran through really quick, and I don't know what my time is like. How am I doing? Yeah?
Yeah, we can take questions.
Okay, if there's any questions. Or was any of that clear? Did I talk too fast? Okay, yeah.
Back to the cron job.
Yeah.
We said that it's a process that you run once and you keep it up.
Mm-hmm.
Why do we schedule it?
Why do we need to schedule the I'm sorry.
Why do we need to schedule it? Is it
Oh.
a process that you just bring up the container and it runs and that's it?
Right, so what we're scheduling is those run commands. So what we're scheduling is it has to run this. This is the way that Embulk runs an actual integration.
Every time you need to extract
Yeah.
information or get upload.
Right.
I see.
Yeah, so it's got to run that. It also has to, yeah. Yeah, so that's it.
So you basically do something like check every minute if the data was uploaded, if it was extracted information.
Mm-hmm. Yeah.
Thanks.
Yeah.
I'm pulling from a couple different sources. Am I having an evolved file for each type of formatting I'm using, or can I have I guess multiple formatting packages for the same evolved file? Like one for
Oh,
my AdWords and one for
yeah.
database.
So each data pipeline is completely separate from the other. They're completely isolated, which is good and bad. Bad because it might cost you more money in the long run. Good because separation, something fails, it's better. So each one you have to launch and deploy separately, and it lives in its own space. Yeah. Yeah. Cool. Thank you very much.
Awesome, dude. Thank
Okay.
you so much.
Cool. Thank you very much, and I appreciate HackerJS for letting me be here.